Okay, today, lesson 11, we move on Newton's second law. So, Newton's second law is about what happens when forces act on bodies. So, when a constant force acts on a body, we noticed that we have constant acceleration. Alright, so then if we change the size of the force, then the size of that acceleration changes so that the force is proportional to the acceleration. So what is it that actually is responsible for that proportionality? So if we apply a different force to different objects, so once those masses are different, then what we get is differing accelerations. All right, and so it would mean then that the property of the object that causes the variation in the accelerations is the mass, which is m. All right, and so then if we combine those things, what we get is that F equals ma. Of course, force is a vector, so is acceleration, but more correctly, we really should write it as the sum of the forces equals the mass times the acceleration. So sometimes you hear that called the net force, and the sum of the forces is the mass times the acceleration. Alright, so a force causes acceleration. Apply a force to same force to something that's heavier, and then you'll get less acceleration. Something that's lighter, you get more acceleration. What is the thing that changes it? And that's the mass. Okay. Thing we need to remember about force, of course, is that it's a vector, so you've got to treat it as a vector. Its unit's Newton, the mass has a unit kilogram, and acceleration is metres per second squared. Alright, what is the Newton? Well, if you stick an apple on your hand and hold it, the force that you feel on your hand is about 1 Newton. Alright, so some notes. So the direction of the acceleration is the same as the direction of the sum of your forces. So that means if your acceleration is 0, then the sum of your forces has got to be 0. And if the acceleration is 0 in any particular direction, then the sum of the forces in that direction also equals 0. Right, so let's have a look at some examples. First one's very simple and straightforward. Example, we haven't got any directions here that we need to worry about. So we just use, and again, the sum of the forces is mass times acceleration. That's Newton's law. We only have one force of 6 Newton. 3 times the acceleration, so the acceleration, divide both sides by 3, is 2 metres per second squared. Alright, then example 2. Okay, so we got a freestyle swimmer whose mass is 75 kilograms, applies a force of 350 as he begins the race. The water opposes his efforts to accelerate with a drag force of 200 Newton. Okay, so here's our swimmer. And so our swimmer is applying a force to the water of 350. Sorry, wrong way. back. So our swimmer is applying a force of 350 to push themselves forwards, and the water is got a drag force of 200 holding them back. So when we look at Newton's second law, the sum of the forces is mass times the acceleration. So seeing as it's just in one dimension, then the sum of the forces, if I take to the right there as being a positive direction, it'll be 350 minus 200 equals the mass, which is 75 times the acceleration. So 150 equals 75A. So the acceleration then would be 2 meters per second squared. All right, one more example number 3. And so we'll look at a little bit more complicated one. Okay, here we've got a body acted upon by two forces, north and east. So if I take north there, here's our body. There it is there. It's 6 kilograms. I'll put a little 6 in there. It's got 3 Newton north and 4 Newton east acting on it. Okay, so we need to add those vectors up, because remember the sum of the forces equals the mass times the acceleration. And of course I've been a bit lazy in the other ones, I haven't put the vector symbols on it. Alright, so let's add those up. So we've got 3 Newton, 4 Newton, that's a right angle triangle, and the sum of our forces would be the green one there, and also we've got a direction, let's call it X. Alright, so Pythagoras says that I'll do it over here, that the sum of the forces squared is 3 squared plus 4 squared. So the sum of the forces squared would be 9 plus 16, 25. So the sum of the forces, square root that, is 5 Newton. Now, of course, we've got a direction in there, and so direction X, if we're using tan, it's opposite over adjacent, so that's 4 over 3, and so we find that that angle is 53.1 degrees. All right. So the net force then where are we? The sum of the forces. The net force is 5 Newton north, 53.1 degrees towards the east, which is all very nice. Now, how does that relate to the acceleration? And I'll do that over here. Well, we know that the sum of the forces is the mass times acceleration. So 5 equals 6A. And so divide both sides by 6, which becomes 0.83. And that's meters per second squared. And don't forget that the direction of the acceleration is the same as the direction of the sum of the forces. And so that is north 53.1 degrees towards the east. All right. So that's it. That's Newton's second law for us. So you've got a set of problems there. There's also some videos on the website. Make sure you have a look at them. And if there's anything in that you didn't understand, make sure you ask me about it.